Hello, and welcome to our next section in Chapter 8. So this is a continuation of 8.4, except this time we use trigonometry still. So that if you want to write, this is trig still. Trigonometry, Part 2. And this is going to be using trig inverses to solve for theta. Now, what's theta again? Theta is our angle, okay? So that means in the first part of this lesson, we were given an angle measure. We had a theta to actually use. In this lesson, we're actually gonna be missing that angle, and we're gonna actually we'll be able to solve for it. So if you'll definitely need a calculator, not a graphing calculator, but it's a normal calculator that has the sine, cosine, and tangent functions on it. And they also have to have the inverse trig functions on it, and I'll show you how to find that. Okay, so to use, first and foremost, let's talk about inverse trig. Inverse trig on our calculator, we have sine theta, and we also have cosine theta, and we have tangent theta. Okay, inverse trig looks like this. The inverse sine looks like this. Sine to the negative first. And cosine, inverse cosine, is cosine to the negative first. It looks like a -1 power. And then tangent is the same procedure, tan to the negative first. Okay? And if you look on our calculator, if it lets me zoom in. Nope, it doesn't let me zoom in. Right above the sine button, in blue, says sine to the negative first. So the way we access that is we hit second, and then we hit the sine button, and then we see that -1, that raised to the power -1, that's the exponent. And you could repeat this for cosine, hit second cosine, and that's inverse cosine. And then second tangent gives you inverse tangent. So that's how we're going to use this today. So give that a shot on your calculator, figure out how to use it before you move on in this lesson. So once you have that figured out, we could actually work with it. And if you were given, let's say, a triangle that looked like this, let's say it is, or I should say, inverse trig is used to solve for angles. Versus regular trig is used to solve for sides. So that's why it's part 1, part 2. Okay? So anytime we have to use inverse trig, we're working with an actual angle measure. Also note, it's also worth noting, make sure your mode is in degrees, just so we don't accidentally end up with an answer that's supposed to be in degrees, but it's in radians. So let's take a look at a triangle. Example. And let's make a right triangle. And we'll use our most common Pythagorean triple, 3, 4, 5. Okay, so in this case, I'm going to actually just erase this 5 for now, just to keep this simple. And I'm going to write our theta, the angle. Let's call this A, B, and C. And let's say we want to figure out what angle A is equal to. So this is going to be our theta that we're going to be working with. And if you notice, we actually have our opposite side, and we have our adjacent side from this perspective of A. Okay? That means we would use our tangent. We would use tangent to solve. But instead of putting an angle measure here, we actually just put theta because we don't know what it is. And then we put the actual trig ratio on the right side. So opposite is equal to 4, adjacent is equal to 3, and we could solve. So how do you solve? How do you get the theta by itself? That's where the inverse trig function works. So what you do here is you actually multiply both sides by inverse tangent. And tangent and inverse tangent actually cancel each other out. trick though is anything you do to one side, you have to do to the other. So you put inverse tangent on the right side of the equation, and then this is what I would prefer you to do. When you do this, especially in your calculator, it's going to open up a parentheses. You have to put this trig ratio, or this ratio of side lengths, into the parentheses. Okay, so on your calculator, well, let's take a look. Theta is now by itself on the left side, which is great. And then on your right side, we actually need to do some trig evaluating. So we do inverse tan, so second tangent, parentheses opened up, and all we do here is put 4 divided by 3. And make sure it stays a fraction. You'll get a better answer. And notice we get a long decimal. So I would go to, at the very least, 1 or 2 decimals. For the sake of this lesson, I'm going to go 2 decimals, 53.13. And if you remember, theta is always an angle. So that means this is actually measured in degrees. So theta is equal to 53.13 degrees. Okay. Now, what happens if I looked at this, if I wanted to know, for instance, this angle? So I'm going to do this in a different color. Let's do this in red. Let's grab red. So let's call this one also theta, but we're going to do a red theta. Okay. And from the red perspective, the 3 is now the opposite side, and the 4 is the adjacent side. Okay. And we could do the math. If we're nope, let's just do the math first, and let's talk about it. We should have still a tangent function because we're still working with opposite and adjacent. So we do tangent of theta is equal to, then we do the opposite over, so it's 3 over 4. And then now we need to solve for theta. To get rid of the tangent, once again, we multiply both sides by inverse tan. Tangent inverse opens up a parentheses. And then I'm going to throw this 3/4 into it. Inverse tan and tan cancel out, and we get theta is equal to, and let's plug this in. Tangent, inverse tangent of 3 divided by 4, close the parentheses, is equal to 36.86, which rounds up to 36.87 degrees. Okay, remember these are angles. And something should happen here, which hopefully we identified before we even started this problem. If this is 53.3 degrees, 53.13 degrees, and this is 90 degrees, it should make a lot of logical sense that the last angle is 180 minus 90 minus 53.3, and that actually does happen here. This is 36.87 degrees. And together, all 3 of these should add up to 180, which they do. Okay? So that is something to keep in mind. So yes, you could always do the trigonometry to it, but if you already have 2 of the angles, you could actually just do some quick subtraction. Now, one other piece I want to show you to this is, what if I actually put that 5 there? So I'm going to do this problem. I'm going to actually redraw this problem. So what if I redrew this problem? I'm going to do the same order, 3, 4, 5. I'm going to use the same perspective, the same original angle theta from our A, B, and C. Okay? And what if I don't use tangent this time? What if I have all 3 sides, which is great, but what if I use, for instance, what if I want to use the opposite side and the hypotenuse? So let's do this in green just to change this up. This is, once again, our opposite side. This is our hypotenuse. And what if I want to use those 2 instead? So this is from our perspective. Okay? Well, Theoretically, this angle should not change because it's a 3, 4, 5. It's the exact same angle from up above. So this should, theoretically, angle A should be equal to 53.13. Now, if we're using a different trig function, it shouldn't change. So for instance, what trig function uses opposite and hypotenuse? Well, that is our sine function. So we'll do sine of theta, because we don't know what it is yet, is equal to, opposite is 4, hypotenuse is 5, and now we could solve. So we do inverse sine to both sides to get the theta by itself. We do the sine to the right, inverse sine to the right side. Take the 4/5, bring it inside inside the parentheses, and we should get theta is equal to, and let's show you the math for this. Inverse sine, oops, I accidentally hit y is equal to inverse sine of 4 divided by 5, close parentheses, is equal to 53.13. So we absolutely did this correctly. 53.13. So no matter what, you would, if you did this correctly, if you use sine instead of tangent, like we did in the original problem, it would still work out. Which begs the question, what happens if I use cosine? Because in the first problem we use tangent, the second iteration of this we use sine. What happens if we use cosine? So let's do this last version of it in the same perspective. This is our adjacent side, okay? And we would use the cosine because what if we use adjacent and hypotenuse? Because that's your cosine function. So we would do cosine of theta is equal to, what's the ratio here? 3 adjacent over hypotenuse 5. We do cosine, inverse cosine to both sides. Inverse cosine, cosine cancel. Take this 3/5, throw it into our group, and we should get theta is equal to, take our calculator, do inverse cosine, 3 divided by 5, close the parentheses, and we get the exact same answer again. So it will always, as long as you set this up correctly, you should get the same angle measure for angle A using all the different trig ratios, okay? We'll have a lot more practice with this, but for now, that's all I have for you, and I'll see you in the next one. Bye.